Hello, my name is Surashish Das, a second year BSMS student of ISER Kolkata. Today I am going to perform the home experiment whose aim is to determine the concentration of an unknown glycerol solution by the process of refraction. Okay, so let's start the experiment. Let's start with the introduction of the experiment. In day-to-day life, we see that if we dip a straw or something in the water, then it tends to bend. So the major cause behind this phenomena is the refraction of the light due to the water present in the prism. Materials required: hollow prism, laser light, 100% glycerol, water, measuring instruments, marker, and a measuring tape. In the next step, we are going to set up the experimental objects to perform the experiment. So first, we are going to draw a straight line in a strip of paper and fixed along a wall with the tape. Then we are fixing the position of the prism at a particular region and going to mark the place so that it does not so whenever we try to lift the prism so that it get fixed in the same place each time. Okay, then we are going to place our laser light such a way that even if we put the light to the blank prism, then the light must get directed towards the straight line we drawn in the paper strips, and then we are going to also fix the position of the laser. So in this way we are actually fixing the position of three things: the laser, the hollow prism, and the paper strips. Now we are going to fix the position of the laser and also the position of the prism using a marker. Now we can clearly see that whenever we light up the prism spot gets into the paper strip exactly in the line we have created there. Now it's the time for calculation. To prepare a solution of 40% glycerol, we need 40 ml of glycerol in 100 ml of solution. In this way, if we see, so in 40 ml of glycerol, we need to add 100 minus 40, that is 60 ml of water. So actually we are mixing together 40 ml of glycerol in 60 ml of water to prepare a solution of 40% volume by volume of glycerol, and in this way we can actually see the refractive angle which is formed by taking different concentration of glycerol here. So we can get a data like that, and in the next step we can feed that data to get the graph like this, and from here we can get the concentration of an unknown solution which we can actually by using the graph. In the next step of the experiment, we are going to measure the distance between the prism and the paper strips which we have kept along the wall. Now we are going to fill the hollow prism with 40% of the glycerol solution which we have created using a measuring cylinder and the ethylene glycol from the chemistry lab. Now, as we have fixed the position of the hollow prism along with the laser, we are going to project the laser light into the prism and see the magic where the refracted ray goes. So now we are projecting the laser into the prism and see the spot formed which is far apart from the strip. So we can clearly see that the strip is quite apart from the laser spot which is formed there using the prism, and this magic is caused due to the materials which have taken inside the hollow prism, which led to refract the light, and due to its refractive index it got refracted far apart from the stripe. Next step, we are going to measure the distance of the line drawn in the paper stripes to the laser spot which is formed. So for this process we need to mark the center point of this of the laser spot which is formed, and now we are going to measure the distance of this red colored spot from the center point of the stripe which is of the stripe where the line is drawn. Now again returning back to our calculation, we obtained that for a 40% volume to volume solution, the obtained D, that means the distance of the mark from the line drawn in the paper strip, is approximately 120.5 centimeters apart. So, and we got the value of D, that is the distance of the prism from the paper stripe, which is about 248.5 centimeter respectively. Now we are going to do all the steps performed in this experiment from the first step to actually getting the distance for the respective solution which we have put in the hollow prism. For now, after performing the experiment, I got the result, that is for a 10% solution I got a 105 centimeter small d, for 20 I got 113, for 25 I got 115, for 30 it's all the percentage, volume by volume percent, B by B percent. I got for 30% 116.5, for 35% it is 118, for 40% it is 120.5, for 45 it is 126, for 90% I got a small d value of 170 centimeter, and for 100% I got 174.5 respectively. Now we are going to put this V by V percent and small d value in the next step of the experiment. I am going to find the angle which is formed by our experiment. This angle, we have this d and this is small d. Now we can use our trigonometric knowledge to get the angle of diffraction which is formed. This angle of diffraction which is formed is equivalent to 2 into angle of refraction on single slides. So let's put our datas in the Origin software to get our V by V versus small d graph. Now we plot the graph in the Origin software, and we can see the relation between the volume by volume versus concentration is a linear relation. Now we take an unknown concentration of glycerol solution in the hollow prism, and then we repeat the steps to perform the experiment. The obtained value of small d is 124 centimeter. Now from this graph we can actually calculate what is the concentration of the unknown solution, and the obtained concentration is about 38%. Thank you. That's the end of the experiment.